Hi, my name is Zarif, and I'm a master's student at McGill, and I'm here to talk about how we're searching for gravitational lens FRBs with CHIME. So first, as an introduction to this topic, let me introduce you to the basic idea of a gravitational lens FRB and how you would identify one. So first, we're saying that there's an FRB, and somewhere along the line of sight, there's a gravitational lens. And this could be anything from a solar mass black hole, brown dwarfs, free-floating planets, or even just regular stars. Now this lens, what it's going to do is create two image copies of the electric field of the FRB that we at CHIME would see as first a bright image appearing and then delayed in time another dimmer image appearing. Now, this entire idea is very similar to the idea of radio interferometry itself, where you have a wave reaching one antenna first and then a little later reaching another one. So, if you treat CHIME as a correlator and you correlate these feeds as a function of time lag, you'd get a spike corresponding to the gravitational lensing time delay. And then the height of the spike gives you the relative magnification ratio between the two images. And both of these observables give you the mass of the lens. Now, the cool thing is measurement is independent of distance, which means that we don't need to know where the FRB is in order to know if there's a gravitational lens along the line of sight. Now, I want to highlight how this search differs from other gravitational lensing searches. So for starters, in the strong lensing case, you search for angularly resolved images of a background source in the night sky. Typically here, the lenses are galaxies and halos, which cause like time delays of months to years. But because our search involves using the electric field to look for an interferometric delay, we don't need images to be angularly resolved, only temporally resolved. This allows us to search for much smaller mass objects. In fact, this is better than the typical microlensing case where images are also angularly unresolved, because we don't need to wait for a lens to complete its transit to know if there is a lens and what the mass of that lens is. So, how do we search for lenses with CHIME? Well, we turn the dynamic spectrum into a time lag autocorrelation at nanosecond resolution. We then search for statistical outliers in this domain to identify possible gravitational lensing candidates. With this method, we should be able to probe cosmological distances for objects between 10 to the negative 3 to 10 to the 2 solar masses. This is really exciting because with FRBs, we really are entering a new domain to search for gravitational lenses in.